one is about key information of parabolas. A parabola is this shape of graph here. It's like a U shape, right? So it's kind of curvy at the bottom, like a U, right? We've got we got a bunch of vocab, actually. I'm going to kind of color code this vocab, so if you like color coding, maybe that's something you want to do. The first thing that we're going to talk about should sound familiar to us. It's the y-intercept. The y-intercept is where the graph crosses the y-axis. So the y-axis is the one that goes up and down, and the y-intercept of this graph is right here at that point. When I'm talking y-intercept, the x value is always 0. So we're going to write these as coordinates. This coordinate would be 0, and then the y value is 5 here. The next part we're going to talk about is the x-intercept. Now, this is going to be like our focus for this unit are these x-intercepts. They're where the graph crosses the x-axis. So here's my x-axis right here. Opposite to the y-intercept, the y value is the one that is 0 here. And then because this is like the focus of our unit, these guys have a bunch of different names that they can go by. So you might see them called x-intercepts. You might also see them called zeros. You might see them called roots. And then the most important one that we're going to see, solutions. And in this example, I have 2 of them. You can see where they cross that x-axis right there. So sometimes they write them out as just like numbers. I want us to write them out as coordinate pairs. So again, the y value is 0. So the first one is 1, 0, and the second one is 5, 0. But you might just see them as like 1, 5, something like that. Questions so far? Okay, the next one, this might be a new word for us. The vertex is either, in some cases, the highest, aka maximum point, or the lowest, aka the minimum point on a graph. So we see our parabola. I don't know why it's not refreshing. There it goes. Here's my vertex. Is that a maximum or a minimum? It's a minimum. It's the lowest point on my graph. So we would, again, call this vertex by a coordinate pair. We're going to look for the x value, which is 3, the y value, which is -4. Oops, +3. +3, -4. All good there. The next one is called the axis of symmetry. The axis of symmetry is a vertical line. Do we remember? We did these acronyms once before. VUX was our acronym for vertical lines. Vertical line, undefined slope, x equals. So our equation will always look like x equals. And a vertical line is going up and down this way. It's dividing my parabola into 2 symmetrical parts. So we can see it here. I'm going to highlight it in purple so we can see it a little bit better. But that right there is my axis of symmetry. It's the same on both sides. That axis of symmetry is always going to pass through the vertex. Therefore, when I write my equation for my axis of symmetry, it'll be x equals, and in this case, it's x equals 3, and that 3 is coming from the x value of my vertex. Any questions right now? Okay. That is all the visible stuff on my parabola. There are 2 things that are not going to be visible, but we still need to be able to do. The first one is called the domain. The domain refers to all the possible x values on a graph. So again, if we think about the x-axis, that's the thing that goes left to right. So basically what the domain means is how far left or right my graph goes. If we take a look at this parabola, if you take a look at any parabola, what you're going to see is on the end, and you should be drawing these in as well, there are arrows on the end. Those arrows are indicating that this parabola continues to go out further than what is drawn on the graph, because obviously we can't draw a line for infinity. But we can use those arrows to indicate that it keeps going. So if we take a look at those arrows, they're pointing up and outwards, which means this graph keeps going up and it keeps going outwards. If you think about getting bigger and bigger and bigger forever, it's going to eventually touch every single number. So my domain, every single parabola that we do, is all real numbers. There is a symbol for all real numbers if you would like to use the symbol. It's a capital R with an extra line through it. So I often use that, or you can just write all real numbers, that's fine too. But that is for every parabola. The other part is range. So if domain tells me how far left or right it goes, range is going to talk about the possible y values, which tell me how far up or down a parabola goes, or a graph goes. Okay, this is one that's a little bit weird. So I'm going to go to my graph. And again, we see those arrows pointing up. That means those numbers are going to keep growing forever and ever and ever, right? But we did say earlier that there's a minimum value that this graph reaches, right? That minimum value is right here. But it touches all the numbers above that value, right? So we have to write that, and we're going to write it as an inequality. So your inequality is always going to start with a y, because we're talking about the y values up and down. And then in this graph, because the graph touches all the numbers above this vertex, we want to say that y is all the numbers greater than or equal to. And then here's another trick. We can look at the y value of our vertex, and that tells us what goes right here. So what this says is that y is all the numbers greater than or equal to -4. Here's -4 right here. Those arrows are telling me that it's going to touch every number bigger than -4. Does that make sense? If this parabola was facing downwards, which it's not in this example, but the other example if I had a maximum value, it would look more like y is less than or equal to some number. This is for minimums. Any questions on that? So that's all the parts of my parabola. I know that's a lot of vocab for us to remember. Are we all okay with that right now? Okay. Let's look at the examples. So the first kind of thing that we're going to do here is talk about all these different pieces. So the first question it asks me is, which way does it open, up or down? And that means, which way is my parabola facing? I have two different ways it could look. It could look like this, where my arrows are pointing upwards. It looks like a U shape for up. Or it could look like this, where it's an upside down U shape, and that's for down. So this parabola in particular is opening up. Look at that. Cute little arrows on there to tell me that that's going up. The vertex is the next part. We're going to label this point right here as 2, -2. And is that vertex a maximum value or a minimum value? Chaz? Yeah, it's the lowest point on there, so that's a minimum. I'm going to draw my axis of symmetry. That's what splits my graph in half. The axis of symmetry always starts with x equals, and then I take the x value for my vertex and put it in there. You can also see it on the graph, right? That's like at 2. Y-intercept is wherever my graph crosses the y-axis, so be careful when you're looking here. This crosses at 6, so I want this as a coordinate. This is 0, 6. Next are my zeros. Remember, zeros is another word for x-intercepts. I have 2 of them here. They are at 1, 0, and 5. Oh, no, sorry, not 5. 3, 0. Domain is the same thing every single time. It is all real numbers. Or you could use the fancy symbol if you would like to. And then the range is the hard one. The range starts with a y. I'm looking at a minimum value. So this graph touches everything bigger than that value, so I want greater than or equal to. And then that number is going to come from the y value of my vertex. Questions? You think you can help me with the next 2? Okay. Flip it over. Look at B. Opens, up or down? Down. What is the coordinate of my vertex? Here it is, right here. What's that coordinate, Chaz? Beautiful. Is that value a maximum value or a minimum? And then the axis of symmetry, let's draw it in first. And then what's the equation for that? Beautiful. That number is coming from the x value of my vertex. Okay, y-intercept. I need a coordinate. Jaden? Okay, here's the tricky part. Roots. What x-intercepts? Zeros. Solutions. Do I have them here? Here's the x-axis. Does my graph ever touch that x-axis? So that happens sometimes. If it does not touch the x-axis, you can just write none. Domain is what every time? All real numbers. And then the range is the tricky one. Here's my vertex. It doesn't go above it, so all the numbers are smaller. So I want y is less than or equal to what? Perfect. That value is coming from my vertex. Okay, again. Letter C, opens up or down? Vertex is at what? Here's the vertex right here. 3, 0. Is that a maximum or a minimum? Okay. The axis of symmetry, let's draw it first. Oops. Go purple. The equation for that axis of symmetry is what? Beautiful. That's coming from this number, right? Y-intercept. 0, -9. It gets kind of hard to see, so it might help you to count the boxes. Zeros. How many do we see here? Just one. It only touches that x-axis the one time. Here's the x-axis. So that point just happens to be the same as the vertex. So that is 3, 0 once again. Domain every single time is all real numbers. Oh, I didn't want that in blue, but that's fine. All real numbers. And the range here. Anybody want to give the range a go? James? Beautiful. Okay. Questions on these guys? Now we're going to take that, what we just did, and we're going to go backwards, and we're going to draw our own parabolas. So take a look at letter A in example 2. It gives us some points to start with. So the first point that it gives me is the vertex. So that's what I'm going to plot first. Remember how you graph a point, right? You have an x value and a y value. So x and y. I'm going to go 2 on the x, 1 on the y. There's my vertex. I have an axis of symmetry at x equals 2. I know that that goes through the vertex. So let's draw that in there. Yes, you do have to draw that part. The next part is the y-intercept. So again, 0, -6. I start at 0. I'm going to go down 6. There's my y-intercept. Now, here's one thing that we can do with this. I know that axis of symmetry, do we know what symmetry means? It's like it's mirrored on both sides. So if I put a point, my y-intercept, on the left side of that graph, what I want you to do is mirror that point to the other side of the axis of symmetry. So I'm going to put it an equal distance away on the other side. So now it's mirrored. Everybody good with that? The last two things I need to put on there are my solutions. Remember, solution is another word for x-intercept. So I'm going to have a solution at 1 and a solution at 3. You're going to draw your parabola. It's going to be a little bit curvy, right? Not like pointy. And you got to have arrows on there as well to show that it keeps going down. Good? Can we do one more and then I'll be done? Okay. First things first, vertex. 3, -4 goes here. I'm going to draw my axis of symmetry through there at x equals 3. My y-intercept at 0, 5 goes up here. And then I'm going to reflect it. So take that point, flip it over the axis of symmetry. Its reflection goes over there. And then the last thing I have is some x-intercepts. One at 1 and one at 5. And then we fill it in. Good. Any questions on this?